Good evening, my dear student. I am Rakesh Sharvik from Sunbeam Sun City. Jai Hind you all. My dear, today I am uploading these few topics which will be left with the ray optics. The first is optical instrument, that is simple microscope. Now, my dear, the question is, what is simple microscope? Define and derive. We have to define and derive its magnifying power. So now, earlier the question was magnification. Now it is magnifying power. I will come down to it. See, how much is the difference in magnification and magnifying power? When you're talking magnifying power, what actually it means? When the final image formed at least distance of distinct vision, LDDV, least distance of distinct vision, that is my dear, that is 25 centimeter is taken as the least distance of distinct vision, and the final image, second case, the final image is formed at infinity. So the first part is that, what is simple microscope? My dear, the simple microscope is a magnifying glass. It is a magnifying glass. You all know that a watch repair, the wristwatch repairs and all that, they are carrying the magnifying glass, my dear, to see the object which is kept near about to 25 centimeter or within that. So it is a magnifying glass and it is made up of convex lens. But that convex lens is having very short focal length. Am I clear? So the 2 point is important when we talk a simple microscope. First is that, sir, it is a magnifying glass. It is a magnifying glass, and it is of magnifying glass of convex lens. This magnifying glass is of convex lens of very short focal length, or you can say of short focal length. So three things are very important, sir. It is a magnifying glass of convex lens of short focal length. Am I clear, my dear? And this is about your simple microscope. Now let us come down to define and derive magnifying power when the final image is formed at LDDV. Now my dear, here I am writing ray diagram when final image is formed at least distance of distinct vision. That is formed at LDDV, I'll repeat, least distance of distinct vision. So now when we draw the diagram, my dear, here, this is the convex lens. This is the optical center and this is the lens, my dear. This is called optic axis. I have kept the object between the principal focus and optical center, my dear. That this is the object placed. The one ray will go parallel to the principal axis and it will go like this. The another ray is going from here, my dear. You can see it is going through the optical center, my dear. You all can see. And here the image is obtained. You can see, my dear. Here the image is obtained. And I will give this, suppose the object is named as AB. So I will give the name of the image as A dash B dash. This is the image obtained, my dear. And you can see the image is virtual, erect and magnified. Look at the way of forming the image. So my dear, the image will be formed. One ray will be go like this. Now I can draw the joint line here. So my dear, in this diagram, as I have drawn, here you can see the object is placed between the optical center and focus. So my point number 1, I can write an object O is AB, an object you can say AB is placed between optical center, that is between O and F, as shown in figure. Okay, now this is the object is placed, and you can see the image is obtained. The image is virtual, erect and magnified image, that is A dash B dash. My dear, let us do one thing. Here if I keep an eye, suppose here is an eye. So whatever angle subtended at the eye is the same angle subtended at the lens. Please, this is also make sure that the angle subtended at the lens by the image is same as the angle subtended at the eye. So suppose this image A dash B dash O, you can see A dash B dash O is forming a image here. It subtend an angle here, you can see, and let us draw this angle as beta. So you all can see there is an angle subtended by the image at the lens. Angle subtended by the image at the lens, my dear, and the same angle will be subtended at the eye also. Okay, this is one small concept you are supposed to know. So, and that angle is beta. Okay. So my dear, here the image which is obtained by keeping the object between O and F is virtual, erect and magnified. That also I can write. An object AB is placed between O and F. The point number 2. Now my dear, when I go for point number 2, you all can see there is an image, and the image is virtual, erect and magnified. So I can find this virtual, erect, point number 2, virtual, erect and magnified image A dash B dash is obtained on the same side of the object, very crucial. And this image which is obtained, my dear, you can see this image is obtained, my point is the image is obtained at what distance? It is the image obtained at LDDV, and LDDV is taken as capital D. So the distance of the image is capital D, my dear. And this I can take it as V, and this is V is equal to D. But no doubt I am measuring to the opposite to the direction of incident ray, so it will be minus D, no doubt. While substituting, I will substitute minus D. So now here you can see these 2 points. An image is forming an angle, my dear. The image subtend an angle at the lens, and the same angle will subtended at the eye also. Okay. Why I am emphasizing on this angle, that is very important, my dear, to understand that why you are saying about the angle. My dear, now we are doing the question on magnifying power. The question is on magnifying power, my dear. And when I talk about magnifying power, you all must be knowing a magnifying power. When we come to the term from magnification to magnifying power, Sonakshi has asked me this question, sir, how much is the difference between magnification and magnifying power? My dear, when you are talking about magnifying power, the right answer is magnifying power of lens. The total answer, the full form of this is not magnifying power only, it is magnifying power of lens. For a time being, bachcho, please forget the magnifying word and try to understand the power of lens. If you remember, I have taught you that power of lens is nothing but, Chaube sir, if this is a convex lens, try to understand. I am giving you a small concept about the power of lens. When you talk about power of lens, my dear, suppose this is a optical center and this is the parallel beam of light, and this is the actual path of the parallel beam of light. But my dear, as soon as it will fall here, this light will be converged at this point. This light ray will converge at this point. Now my dear, here what we are doing, we were asking the student, here is an angle, that angle is called delta. Remember, we have done this topic while Zoom meeting, that power of lens is not only the reciprocal of focal length of the class 10. Now the power of lens is the angle, is the tangent of angle by which the ray converges or diverges. In case of concave, it will be diverges. In case of convex, it will converge. So this is the parallel beam of light. So this is your parallel beam of light, my dear, and this parallel beam of light is converges here, you can see, is converging here at this point. Say I will make it as F, and this is converging by what angle? By tan of delta, tangent of delta. And if I observe, here it is delta, so I can draw delta here also, my dear. And if I draw this distance, let this distance here, say here it is A, and here it is B, or optical center O. So this distance, if I draw, let this distance is H. Let this distance is H. And everybody can see from figure, this distance is F. So now what is tan of delta? My dear, the tan of delta will be H by F. The tan of delta is become H by F. Try to understand, my dear. And here we define that power of lens is the tangent of angle. It is the tangent of angle, and it is denoted by tan of delta. So what's wrong if I denote here tangent of beta, magnifying power for image? What's wrong? Only power is in terms of tangent of angle. But this is a magnification power, that is magnifying power. So of course, Chaube sir, magnification का थोड़ा सा rule अपने को मालूम है, it is a ratio of image to the object. But since it is magnifying power, so it is a ratio of angle by the image subtended at the eye to the angle by the object subtended at the eye. Angle concept. Because power itself is a tangent of angle by which a ray, by which a beam of light converges. A beam of light converges, or a beam of light fall at a tangent of angle by which a beam of light fall at unit distance, or a beam of light, you write this way only, by which a beam of light converges or diverges, which falls at unit distance from the optical center. from the optical center. Try to understand. Oh God, unit distance from the optical center. It means this beam of light is falling at unit distance. It means, my dear, according to definition, h become 1 unit. So if h become 1 unit, because language say it is a tangent of angle, that's a power. And therefore whenever we go for defining magnifying power, so magnifying choice are of course the ratio of image and object. Earlier also. But now it is magnifying power. So it will be tangent of angle, my dear. Tangent of angle by image to the tangent of angle by the object. Tangent will become. Angle will become. Because it is magnifying, not only a magnification, it is magnifying power now of a lens. And power of lens is this. It is tangent of angle by which a beam of light converges or diverges, which falls. It falling at unit distance. You can see at unit distance from the optical center. So sir, h will become 1 unit. So the formula will become, therefore, tan delta can be taken as delta because angle is very small. This is a small angle, we all know. And that paraxial angles are very small angles. So tan of delta is equal to h by f will now become 1 by f. And this is become power of lens denoted by P. And you all know, my dear, now it is power of lens is a reciprocal of focal length. Reciprocal of focal length. But my dear, when it become reciprocal, when the numerator become 1, when I have taken this concept, it fall at unit distance from the optical center. So this is the reason why, my dear, whenever we are going for magnifying power, when there is a magnifying power of lens, it is not a magnification, it is a magnifying power of lens. So Chaubesar, of course, you have to take the tangent of angle by which the image and the tangent of angle by which the object make an angle at the eye, subtend an angle at the eye, tangent of angle. Because power of lens is a concept for tangent of angle. This is a small concept from my side, my dear, so that you should understand any question on magnifying power. You require no doubt it is a magnification. So of course it is a ratio of image to the object, no doubt. But Chaubesar, it is not only magnification, it is magnifying power of lens. So since it is a power term related, so of course it is a tangent of the angle, Chaubesar, by the image which subtend at the eye to the tangent of angle by the object subtended at the eye. So this is, my dear, a small concept. Please you note it down so that I wipe it out. I will clear it out from here and I will continue the topic. Now, my dear, there is a after knowing the power concept and how the power of lens is defined, and I have told you that the image making an angle at the eye or at the lens of beta, that is the angle subtended by the image, my dear. I have drawn earlier in my diagram. Now, my dear, there is one small concept which I supposed to tell you. I have not jotted here, but I am waiting for that. Now, the concept is, my dear, this is a magnifying glass of convex lens of very short focal length, microscope, simple microscope, and it is held close to eye, which is held close to eye. So, my dear, if it is held close to eye, I don't think, bache, you can imagine that if the glass, if this lens is kept very close to eye, so no doubt the angle formed at the lens will be angle formed at the eye. No problem. But my dear, even the object, here in my diagram, the object is placed between optical center and focus. Okay. But you all know it is a normal human eye, a normal human vision, that every human vision can easily, if it's a normal human eye, it can easily view up to 25 centimeter. Any human normal eye can view, my dear, 25 centimeter, that is up to distant object. least distance of distinct vision, that is 25 centimeter, and in normal human eye. So now my dear, what is our imagination consideration? That assume that this object which is close to this, that is between optical center and focus, assume that I have taken this object. Imagine that this object is taken to the least distance of distinct vision. Imagine that the object is taken, this is the concept of this topic. Suppose an object, because normal human eye can see the up to the LDDV, that is up to least distance of distinct vision. So assume that I have shifted this object. Imagine I have shifted this object. Consider I have shifted the object AB to this distance, to the distance D, to the least distance of distinct vision, like this. Say here I shifted. And now my dear, this is the line I can draw that I shifted the object. And the new position I named it as A double dash B dash. You know what happened because of this? As soon as I shifted the object to LDDV, because a normal human eye also can see the things clearly at least distance, up to least distance of distinct vision. So why don't I shift my object? I have shifted the object in my imagination. Am I clear? Now what is happening? The object is now lying on A double dash B dash. What is the meaning of this? Oh God, the object and the image both are at least distance of distinct vision. And assume that this make an angle here at the lens. This also make an angle, my dear. The object now making an angle. Earlier it was image make an angle. Now the object make an angle at the lens. And let that angle is, my dear, I am denoting here. Let that angle is denoted by alpha. Alpha. So now it is very clear in my figure that the angle alpha is subtended by the object, which is imagination. I shifted it to LDDV. And our image is obtained also at LDDV. That's a magnifying glass. So my dear, this is what is the important concept here. And the concept is, since the normal human eye can see the object clearly at LDDV, that is 25 centimeters. So imagine object which is at AB, object AB, I can say, displaced to position A double dash B dash, that is at least distance of distinct vision, that is at D. I have shifted this object to the least distance of distinct vision because a normal human eye can see up to 25 centimeter, my dear. What's wrong? And then from figure I got another angle, my dear, and that angle is nothing but angle A double dash OB dash, and that angle is alpha. You all can see in the diagram. And the next line is that after doing this, we can adjust the convex lens, my dear. So it is not so easy now, my dear. Now I will adjust this lens, convex lens, and by adjusting the convex lens, my dear, we obtain the image, the final image, which is virtual, erect and magnified. So I adjust this convex lens now, and by adjusting this convex lens, I obtain the final image at least distance of distinct vision, my dear. And now you can see in the diagram A dash O B dash is beta, or you can see AOB. AOB is also beta, you can see from figure. So now, my dear, this is an important concept and small minute concept that's a normal human eye can see up to LDDV. So if object is displaced to LDDV, there is no harm. And my dear, as soon as I shifted the object at LDDV, I can see clearly the angle formed by the object at the lens, and that is alpha. An angle formed by the image at the lens or at the eye is beta. So this is what the concept, and now if you look the final diagram, my dear, The final diagram says that, sir, Chaube sir, the object as well as the image. Object is A double dash B dash. A double dash B dash, no doubt it is equal to AB, no doubt about it in size, you can see. But the object A double dash B dash, which is imagination may displace to the position D, and the image which is obtained at D. So here, my dear, take care, both image and object, both are at least distance of distinct vision. Both are at least distance of distinct vision. That is important. So I hope everybody is clear with the concepts. So this is all about, my dear, a small writing part while doing this topic. So in writing part, my dear, this writing is for your understanding so that you can understand what actually is happening in diagram. Otherwise, you can directly start from the derivation also in the exam. So in the exam, my dear, you can only the important point is that this one, that which type of image is obtained. So the image obtained is nothing but a virtual, erect and magnified on the same side of the object. And second important concepts are object and the image. Both are at least distance of distinct vision. Am I clear, my dear? Sir, but you said the object is placed between O and F. Okay, my dear, I said, but now what is the point? I'm saying that the object can be clearly seen by a normal human eye up to LDDV. So with this concept, my dear, if I can see the object up to LDDV, up to 25 centimeter, with the normal human eye, I have shifted my object. In imagination, I imagine karo ki I have shifted the object to LDDV, my dear. Am I clear? So as soon as I shifted the object at LDDV, it also making an angle. I can define that angle alpha. Am I clear? I can define that angle as alpha, my dear, by the object. So try to understand the concept that imagine the object AB displaced to the position A double dash B dash, that is at D, because we can see up to a least distance of distinct vision, normal human eye. So A double dash O B dash, A double dash O B dash will be alpha from here. And by adjusting the convex lens, my dear, we get a virtual erect magnified image also at least distance of distinct vision, which make an angle beta, and it is given by my figure A double dash A dash B dash or A dash O B dash, or in the figure you can see it is AOB also. AOB also is an angle beta. So you can see from the figure, my dear. Now, my dear, let's go for definition of magnifying power and the derivation for the same. Go for magnifying power, definition for this topic, for LDDV and the derivations for the same. Now let's go to the derivation for magnifying power for LDDV, my dear, after explanations of the ray diagram and the theory concepts. Now what is magnifying power? So the magnifying power is, I am writing here, magnifying power, and it is denoted by small m only, the magnifying power, and it is the ratio of, I am writing here, ratio of angle subtended by the final image at the eye, to the angle subtended by the object at the eye when both means cone, image as well as object, when both are kept at least distance of distinct vision, and in short form you can say LDDV. This is the definition, my dear. So easy. And of course, I told you any power is the tangent of angle. Any power of lens is a tangent of angle. But it is magnifying power, so it is tangent of angle by image to the tangent of angle by the object. So nice. So now here, my dear, therefore this will be nothing but m is equal to, the very important word, because magnifying power definition will keep on changing, my dear. So here it is the concept where the magnifying power for least distance of distinct vision. Here the concept is that the image and object both are kept at least distance of distinct vision, and we are calculating its magnifying power. So whenever we write, it is a ratio of, so here I am writing angle, therefore angle subtended by image at LDDV, kept at LDDV, to the angle subtended by object kept at LDDV. So both are at LDDV, my statement saying that. So now here, my dear, from figure, this is small m is equal to tan beta, or you can say angle subtended by the image is beta and angle subtended by the object is alpha. So now, my dear, you all can know if tan beta is written as beta, if beta is and alpha are very small angle, you all know that. So if beta can be written as tan beta, because tan beta can be written as beta. So here tan beta divided by tan alpha, now it is converted into power tangent of angle by image to the tangent of angle by the object. Since it is tangent of angle, the term takes as magnifying power. So magnification because of image to the object, and the power is a related word because tangent of angle by the image to the tangent of angle by the object, because I have given a concept for power is nothing but a tangent of angle by the ray converges, which are falling at unit distance from the optical center. Take care. Many students have asked me this question: what is the difference between magnification and magnifying power, my dear? This is also called angular magnification also. I will tell you in next my numericals also. So now here it is tan beta by tan alpha, and here since I can write, since alpha and beta are small, so we can write this way, sir. So therefore this will be nothing but m is equal to tan beta. In the diagram, my dear, tan of beta, you can see tan beta is nothing but opposite upon hypotenuse adjacent, that is AB divided by OB. AB divided by OB will be tan beta. In my earlier topic I have told you that AOB is beta. So tan beta will be, opposite side will be AB and adjacent side will be OB, whole divided by tan alpha is nothing but, my dear, A double dash B dash divided by A double dash B dash divided by, my dear, you can take it OB dash. This is alpha. My dear. You can see tan alpha will be nothing but tan of alpha opposite upon adjacent. So opposite is A double dash B dash and adjacent is OB dash. You can see. So now, my dear, I hope you are understanding this part, that it is how it is A double dash B dash upon OB dash. So now here, if I go further to solve this will be therefore m is equal to, my dear, further if I solve, since A double dash B dash is equal to AB only from figure, A double dash B dash is equal to AB from figure, my dear. So now m is equal to, my dear, if I go for this is AB upon OB whole divided by AB upon OB dash. So this will give me OB dash divided by OB. This will give me OB dash upon OB. Therefore, small m is equal to OB dash, you can see, minus D. and OB is minus x. OB dash is minus d and OB is minus x. And minus cancel, it is d by x from figure. I hope everybody clear about this. Now remember my dear, application of this topic is very well you should aware about. This d by x is a formula of simple microscope when the image is formed at LDDV. Please take care of this word what I am saying. So d by x is the formula, x is the object distance you can see in the figure OB. So this d by x is a formula chobe sir when the image is obtained at LDDV by simple microscope. Okay. Now my dear, as soon as I will go to compound microscope and as soon as I will go to the telescope, please, this is a very golden line I am going to speak to you. As soon as I will go to the simple compound microscope and telescope, my dear, there will have a concept of two lenses. One act as the objective and other which is kept close to eye. Other which is kept close to eye will act as the eyepiece. Since my dear, I already said that the simple microscope is that instrument which is kept held close to eye. So what will happen in my next all topic? The eyepiece of compound microscope and the eyepiece of telescope which is kept close to eye, my dear, are act as a simple microscope. They will act as a simple microscope. Please, this is a golden line. In compound microscope and telescope, as soon as we go to the topic, there will be two lenses, objective and eyepiece. The eyepiece is kept close to eye. And here also simple microscope is kept close to eye as a concept given, my dear. So as soon as the eyepiece is kept close to eye, my dear, in other instruments, such as compound and telescope, my dear, that eyepiece, the eyepiece of that all instrument, compound, telescope, they act as a simple microscope. They start acting as a simple microscope. So what will happen, as soon as the simple microscope, as soon as the eyepiece forms the image, because eyepiece will form the final image, my dear. So as soon as it will form the final image, remember that we have to use the concept of simple microscope for those topics. Okay, so now today it is d by x because I have said that this is, suppose, my eyepiece, this is my lens, this is my objective also, my dear, because object is seen through the naked eye. Am I clear? You can see. So now, my dear, here this eyepiece or this object which is there, my dear, this objective lens, this lens which is there, my dear, will be next for all the cases, will act as a simple microscope. So as soon as this distance x which I have written here, it will keep changing, depend upon the distance from the eyepiece. So please take care this language, that in my next all topic, in compound microscope, in telescope, the eyepiece of that instrument act as a simple microscope, and as soon as I will say they are a simple microscope, we will start applying the concept of simple microscope there for image forming at LDDV and for image forming at infinity. Take care. Am I clear? So remember, this is a very important statement from my side. Sir, in next all optical instrument, the eyepiece of the instrument, because in compound and in telescope we have two lenses, one is objective and other is eyepiece. So the eyepiece of the instrument are start acting as a simple microscope. So whatever concept we are studying for simple microscope, for the image forming at LDDV and for the image forming at infinity, we will start applying the concept there for the eyepiece of the compound and for the eyepiece of telescope. We will paste this concept there as soon as we will deal with the eyepiece of those instruments, because eyepiece of those instruments are simple microscope, act as a simple microscope. Please take care. So right now it is d by x here, the magnifying power for LDDV, I got it. Now my dear, the science want this formula should be elaborate in terms of focal length of the lens, because when I say it is a magnifying power, see, Unless until if I say magnifying power of lens, immediately student give a thought, oh God, it is a magnifying. Okay, power of lens. Okay, it must be reciprocal of focal length something. Reciprocal of focal length something like that. So my dear, no doubt the answer is d by x, you understood. We can apply in the numerical also. But try to elaborate the formula in terms of focal length of the lens. So when I need a formula in terms of focal length of the lens, so I am here writing formula in terms of focal length of lens. Let us see that you all know that by using thin lens formula, it is 1 upon V minus 1 upon U is equal to 1 upon F. Okay. Now my dear, you all know, you can see from figure V is equal to minus D and U is equal to minus X. So if I apply there, this will be 1 upon minus D minus 1 upon minus X is equal to 1 upon F. So now this will be minus 1 upon D plus 1 upon X is equal to 1 upon F. So now this can be written as 1 upon X is equal to 1 upon F plus 1 upon D. Now let us take, my dear, 1 upon D common. So if I take, my dear, 1 upon D common, if I take 1 upon D common or if I take 1 upon F common, now you can see what will happen, my dear, if I take, my dear, 1 upon D common. So 1 upon D common, so this will be 1 plus D by F. One plus D by F will be the formula for 1 by X. And everybody can see, Chaube sir, this is 1 plus D by F. Oh God, by taking 1 by D common. So now here, you can see it is 1 by X in the numerator. So now, my dear, what will be the formula if I take this is 1 by X is equal to 1 by D into 1 plus D by F. Or I can give one more answer. I can say here, I can do one more step like this, dividing throughout by D. Sorry, multiplying throughout by D. Multiplying throughout by capital D. We get, so here it is minus D by D plus D by X is equal to D by F. Minus D by D plus D by X equal to D by F. Now this will give me, my dear, therefore this is minus 1 plus D by X is equal to D by F. So therefore, my dear, D by X is equal to what? So D by X is equal to, my dear, I got 1 plus D by F. So now, my dear, you all can see, oh God, I have converted D by X formula. D by X formula in terms of focal length. So now, my dear, we can all say that magnifying power for LDDV by using simple microscope, the magnifying power for LDDV is equal to 1 plus D by F using SM. SM means simple microscope. So this is the formula, my dear, for magnifying power when I say the image formed at LDDV. Thank you. And now let's see for infinity.